So here we are. This is CPM Calculus, Chapter 2, Number 23. We see Sarah here designing her roller coaster, and follow it. The first section for x is less than or equal to 0 is one cosine function. For x is between 0 and 2 pi, it's another cosine function. And for x is greater than 2 pi, it's even another cosine parent function graph. So we can do this problem in two different ways, which I'm going to show you right now. The first is going to be looking at it graphically. So if we are looking at cosine as a parent function, let's quickly go over cosine, where here's the y equals cosine graph. You can see the amplitude is 1, so it reaches 1 at its maximum and -1 at its minimum. It has a period of 2 pi, so we see that it oscillates between 1 and back to 1, and then it repeats from 1 to -1 back to 1 every 2 pi. Okay, so once we look at that, we can actually go ahead and look at the first definition in the piecewise function for x is less than or equal to 0 is the cosine function with a couple of transformations. The -2, basically, remember the negative is going to flip or reflect the graph across the x-axis, and the 2 is going to stretch it and pull it in the vertical direction by a factor of 2. And then we have to go up 3 units because of the +3. And so here in blue, we see this function defined from for x is less than or equal to 0. So we stop here at x equals to 0, and then let's go on for the third section, which is defined. It starts here at x is it's 2 pi, and so and this function it has a few things going on. There's a few transformations from our parent cosine graph. There's a negative sign in front, so we're reflecting across the x-axis again. There's a 2x in the input, so we're actually going to horizontally shrink by a factor of 1/2, and then -4 as we're shifting it down by 4 units. So here's the graph of that below. And basically, we have a third cosine function in the middle, and we want to just connect this point. Let me start over here. Sorry. We want to, let me undo this. We want to connect this point here or here with this point down here. Let me put another color so it's easier to see. Our goal is to connect this point here with this point here. And if you just look at it, you'll notice that we want to use a cosine function. So if we do it graphically, we can kind of sketch it. And we see that it starts here. We needed an amplitude of 3 to cover the whole 6 units from 1 to -5. And we want to stretch that by the cosine by a factor of 2. So if we make b 1/2, it starts there and ends where we want it, and we seem like we're pretty good. But we have to look a little further and notice that in the question, Sarah wants one peak in the middle section. So that means we can't go with this. Let's go back here. We cannot go with this because there's no peak. It just decreases all the way in green from beginning here at x is 0 to x is 2 pi. So let's take that out, and we need to add in one peak. So here we have our peak right here. So it decreases, it peaks, and it decreases and hits our point where we need it to end. So that's where A is, of course, 3, because we need it to stretch across vertically and cover 6 units. And B then is going to be, if you look, between 0 and 2 pi, we're fitting in 1.5 of our cycles. So B has to be 1.5 or 1.5. So there you have it. F of x is equal to 3 cosine of 1.5x minus 2 within the middle region, and that connects the roller coaster and gives us one peak in the middle section. Okay, so that's one way of looking at this problem. Another way of looking at this problem is basically algebraically. Okay, so algebraically, we're not going to care too much about how the graph looks, even though we already we understand it graphically as well. So first, we're going to notice that here, graphs, the first piece and the second piece intersect, or they should come together. So at x equals to 0, we want the first and the middle sections to equal each other, right? We want them to intersect. So if we do some algebra, we have x equals to 0. So we plug that in. We continue to simplify. We do a little more, and we are left with, let me move this down a little bit and to the right. We are left with f of x is equal to 3 cosine b of x minus 2, because we solve for a and we get a is equal to 3. Okay, so then to solve for what b is, we can plug it into the second half over here. Oops, let me write that a little better. We see our second point is that x is equal to 2 pi, where they should intersect again, and we can look at the second and third sections should equal each other at x is equal to 2 pi. So we have a being 3 now, cosine bx minus 2 is equal to negative cosine of 2x minus 4. Okay, so if we plug in x is equal to 2 pi, and then we just kind of simplify it, we know negative cosine of 4 pi is our negative 1. And because cosine of 4 pi is 1, we make that negative, so we have negative 1. We do a little more simplification. We get cosine of 2 pi b is equal to negative 1. So, so you might be able to just say right away where this is true. But if you remember our cosine graph, it oscillates, and we are going to look basically where these points in blue at the bottom are where the graph touches negative 1. So it's basically pi, 3 pi, 5 pi, 7 pi, every odd pi, even negative pi, negative 3 pi, and so on. So we want what's in the inside here. Oh, let me change the color really fast. But we want what's in the inside of cosine 2 pi b equals to negative 1. We need that 2 pi b to equal to pi, 3 pi, 5 pi, 7 pi, or whatever. So if we solve for b, we divide both sides by 2 pi. Pi divided by 2 pi is 1/2. 3 pi divided by 2 pi is 3 over 2, because the pi's are canceling out. So you can see that there's a pattern where b can be 1/2, 3/2, 5/2, 7/2, so on. Okay? And then we want to just make sure we look at, we know that we have a starting point here at x equals to 0. It cycles down, and this is where b is 1/2. It cycles back up, it cycles down, and b is 3/2. But we need this peak, because as she says in the problem, we want one peak. So this is where we have to kind of think both algebraically and graphically to understand that to get one peak here, we need b being 3/2, and not 1/2, and not 5/2, and so on. So b is equal to 3/2, and we have in our conclusion, we could box our answer right here. A we know is 3, b is 3/2 or 1.5, and that will give us exactly what Sarah wants, where these three functions flow continuously and there's one peak in the middle. Okay.